Yo, yo, yo. Alright. Hey, what is up, King of the Monsters? Bro Sib, what is up? Sorry for being just like hiding off in the dust for a second. I was getting stuff shared on the Twitter. Alright. So what are we looking at? What are we looking at? So basically, I have taken the time out to vibe code, and I mean that, like literally vibe code. Um, and I just kind of want to show a bit of that process because it's not like what people think. So we're gonna, as you can see, I'm getting stuff pulled into the display. So we're gonna let you look at this for a second. But what exactly is this, right? Well, this is a simple little like Python program that is basically just a map editor. Right now, the intention, I guess, or whatever, is that to get a system. I want a pixelated dungeon crawler where I had the ability to build maps through text editor. All right, but I want three dimensional on a 2D plane. I'm just trying to figure this. So I want fake three dimensional um, scenario in the game system or the files for the actual map, so that way any game engine could use it. What up, Roadkill? What up? Um, And yeah, like I said, this is 100%. Well, I say 100%, so it's like 99, 98% vibe coded. I've been using a different product, and I started using this one too to actually learn Python myself. I'm just, I've actually tried more than once to learn Python. I'm really, really bad at it. Exactly. This is how to get you your own Skynet. You know what they say, to fight Skynet, you'll need your own. And that is what we're doing. So, we're gonna bring you guys back into the fold. All right. So we are and yes, roadkill. It does definitely sound like it. So we're on Grok. You see, it's super Grok. I'm paying like $30 a month or whatever. Um, that alone, the Grok system, the all these AIs right now, they're kind of designed to fuck with you. So there's lots of times where like just in this program alone, I spent 2 days where the program would not every every prompt resulted in just getting a repeat of what I gave it. Never changed anything. 2 days did nothing. So if we look on the side, you can see there's a ton of um, just wow. I was actually working last night. It's considered today. Going here, see, working on this stupid thing, working on things. We have to constantly come back to it. Start over, start over. And I'm not starting from scratch. I'm taking the program I have and I'm giving it to it, and we're starting conversation with the program over. So that's an important step. So if we was to hit like open or whatever, and you see the actual files that we were dealing with, you can see I have a ton of like just this one version. There's a ton of these, right? Here's all of the versions. Now this is for a different file. This is something completely different. So let's go to what we're working on right now. Is pixelated backrooms. Here is just pixelated backrooms. This is just the program we're talking about today. Um, well, I'm glad you guys. I'm glad Roadkill and Kingdom Monsters can be in here to uh, do this with us. I am actually going to see if I can do something. Pop out. Cut that chat property. Okay. All right. I'm gonna attempt to smuggle some chat into the. I don't know if it's gonna work. Sorry. Um, so I have the chat thingy on. I don't see. Yeah, it's not popping. I'm sorry, guys, but I can see you guys. But anyways, so this is just for so you basically every iteration that runs, I save a copy. Um, so if it runs, I save a copy. If it doesn't run, I just go over the same file until it freaking runs. It has failed me that way before, but It's actually the best way to do it, or else I'll end up with thousands and thousands more of the. That means that other one we were looking at, all those versions work. They all do something, right? So we were in Visual Drive Mapper. So all of these work. All of these work. So we have a ton of working versions. Just what's different? 9 times out of 10, more bugs. It might work, it might run, but you have bugs. So we're gonna go back into it. Here is the program in question. This is what I've been vibe coding. It started off just me basically being like, yeah, I just want to make a pixel dungeon. Um, I think the map was the only thing I really had any idea about. And so what do we got? We have a ton of options over here on the side. Um, I cannot zoom in. Sorry. Like I'm just like sitting here realizing I'm normally on a web system. I can always zoom in. Dang it. Okay. Anyways, we have like walk space. That's what's automatically on the field. Um, then we have something called non-existing and untouchable land. Something I need to do set up is where it just puts this like a border this whole way around the edge. For some reason it's having a hard time capturing where the edge is at if you don't have something like on the very edge border of the actual file size. Now the great thing is if I don't like the file size, I'm like, 48 by 24. Are you serious? I want to do like a boss battle. That's fine. Let's do like 128. Oh wait, hold on. See, I just found a bug. It does not capture my cursor properly because it's designed where wherever the mouse is, it selects that zone. So when I move out of that area, it now selects this zone over here for like very like oh I got yeah. So I can just me using my mouse wheel heals me holding shift and using my mouse wheel. So I have full control just by being in the zone. Then I can click and it does stuff. Then if I want, I can go over and I can say, look, I need to select something. And now we can actually select things. You see now properties pulls up. I can, well, let me select the whole kit caboodle and put in non-existent. Oh, wait, I know. We go into edit and we say replace it. Now, edit and now deselect. Okay, boom. All the spots have now been filled. Boom, boom, boom. Then you're like, whoa, 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 what? So we can just go in here and we can I clicked on walk space. I'm basically adding walk space. Easier method. Go back to select. I'm already selected on it. Place it. Deselect. Oh, hold on. Something went wrong. Let me try that again. See, sometimes it gets confused and it puts in something that that's not supposed to be there. Because basically, property selector, what it was set on, the select tool is a property selector. So that's what actually is what's being done there. And like we have things like here where that's got like stuck, but we just have a button for it. So now, what's like non-existing untouchable land? Land you can't touch. You will die if you touch it. You'll be called a cheater. Game can basically go, oh, it's an anti-cheat zone. So it's that easy to make an anti-cheat zone. Go there, will kill you. The game engine will kill you and call you a cheater. And then it will tell you what program pulled that, which is going to be you touch land, you touch untouchable land. But we do have land. So say I want, no, I'm like, bruh, you got to be joking me. I just want like a zone that, like, the user just cannot actually, like, okay, maybe perhaps there's a way the user will find a way or whatever to approach onto this land, but it won't kill them. Right? It's just like nothing will render there. If that makes sense. Oh, it's called not part of the map. So we can say this little area, not a part of the map, nothing will render there. It's just a void. So cool, right? So then we can say we have this barrier, right? Now we have these barriers, and then we have got some Now we're building. Guys, we're now building. We're officially building a map in 2 dimensions that has the ability to handle 3 dimensions. For example, um, if in the game engine I want to assign, for example, some special interaction, we can actually go, oh, look, we have an interactable object. Okay, so I want the user, the player, to be able to interact with that. All right. Now I'm going to come over here. I'm going to get property selector, and I'm going to select it, and we're going to give this a value of 9. You know what? No, better yet, let's make this 1. I want this to be the first goal the player sees. Player is going to be like, bruh, what's my first goal? And the first thing it's going to say is, you're on the map? Good. Get that fucking thing over there. Touch it. All right, awesome. Now we have an object, a symbol, a location on the map, and a value. Let's go ahead and give this thing a name. You know what? That thing there. Boom. Very, very unique. Now, you know what? I want the players to see it. It's orange. Let's go ahead and apply that effect. It just changed on the map. Did you see that? That's happened in real time. I can lock this and start applying more of these. So we're going to go ahead and do that. And we're going to do one more. Okay? Watch this. Right there. I want to put it there. Oh, 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 oh. Hold on. I might have messed up because I did not have the same thing selected. I thought I did, but I didn't. I forgot I went. And see how it reset? It is actually that kind of smart. Like, we have it locked, but it noticed that we changed. And it's like, well, I can't apply something to something that changed. Boom, got it back. Boom, done. Roasted. You know it. So it was that simple, that easy. That took like 8 hours to actually get the AI to figure out how to get that to work properly. And I was given it very explicit instructions. So it gets to a point where sometimes you have to know processes that you're going to have to deal with. You might need to know what dependency or anything. And now this is done 100% Python 3 hyphen TK. So that is a specific form of Python. It's specifically Python 3, which allows you to have something called T Tinker, which is like K Tinker. Like, if you just flip the K and the T, it's K Tinker. Dead serious. And what that really means, when you have Tinker Toys, you remember how you would build stuff with Tinker Toys and you to make outline shapes and things. So basically, it allows you to make menus, interactive things. It's actually how this entire menu is set up. Now, you're probably noticing, bro, your menu looks really great. Well, I downloaded this shit off your GitHub, and it did not look so good. Believe it or not, it does not always. I'm going to move it to a different monitor. So I have multiple monitors. I'm going to move it to a different monitor. And you're going to now look at that. That don't look so good. Where'd all my stuff go? Believe it or not, it's still on the monitor. It's just out of view for you guys to. We're going to adjust this. We're going to do this in a manner where if. I know I just took it away. My computer is being mean to me. It's telling me I have to make it full screen. So, we are going to make this nearly the same size screen. Keep it so that you can see this one. This screen is obviously vertical. It's a horizontal screen in the vertical axis. Therefore, it's a fun way. So we can come in here and we can go, oh, well, you know what? Um, raise this up. I can see. Pull them in. It's not let me pull them in because I need to pull. Well, I guess we don't have enough room on this one to actually pull them in. You'll see what I mean. That or we have an error. Find out for sure if there's an error. So basically, we can do a bit of move. Yeah, we didn't have enough room to move them anymore because it's not. We need a cell phone setup. Hey, look, I figured out something I need to add on. Let me write that down. So I got a pad and paper and pen right here of what do I need to do next, basically with these notes. So um, awesome, found something new. So when I change these or whatever, it actually remembers where you put it, and it will load back. So, and I'm still getting it worked out, but it's supposed to be set up to where um, it looks at the screen dimensions and it uses that for the data in a manner to where it should theoretically be able to store multiple things. So you're able to have multiple of these storage saving things that told them how to put the screen back in place per monitor. Um, now the we're going to go ahead and let's go ahead and do this. Let's go file, and we're going to save and exit. It's going to do an auto save, and you see I even have my own. Oh no, you can't see. Holy slaps! Finally, something worked right. Here's a secure pop-up element. It's not actually secure. It just hid itself from the thing. We have our own filing system, so I've made my own file systems. We have MapD, and they're not really special. Don't worry. But if we go, like for example, if we go into the maps, we can see that we have a bunch of maps here, and like here's a team map. This is what team map looks like. Now this one actually is incorrect. This is the old one. Um, so let me see if I can just pull back that one. Is something still going? So you can see that there's still problems, issues, getting stuff figured out. That's actually what this whole thing stream is about. Is I need to test everything. There's so much that's been added, so much that's going on that I'm. Oh, and I don't. Here's a. Actually, this one worked because this is one of the ones where I was testing edge cases and which side can't put spacing on. So you can't put spacing on any of the left side. That's where the error really. In the top. So you notice you're spacing on the bottom that opens up all the way through, and this basically shows like an island separated by some gap, the other landmass that basically is saying, hey, look, this is out there. There's any boss out there. There's a boss store out there, which would then take you to a boss zone to fight the boss. There's a big block of wall of mini bosses, basically. All those M's equal a mini boss. And the ideal there is that because there's land outside and inside, so they would start all over the outside of the building and just like tumble over everything. And this kind of shows like how you can have 3 dimensions within that 2 dimension. Now, one of the things that was a problem here is it doesn't store. It's supposed to be a big old long array to represent each and every one of these little boxes. Each and every one of these little objects is supposed to have an array. There's data inside, and if it's on if it's a special symbol, it should have to automatically have one. So that allows me to have spaces that have array points and so we're obviously having problems. But that's also an older one. So you can see we have different. Now I want to do something brief. Is we're going to cut this, paste it, this one file in here. So this is something that I I I just randomly thought to tell it to do this, and I said it in the wrong way, which went from you do this to have the program do it. And it's kind of cool. So we have a file that is a map text text map file, and then that's printable, by the way. Those text maps you can print them on house printer. So now we have these auto saves. Let's go to the last one. So we can see this is actually our arc that we didn't fill out. It was just that's the basic. Let's go to the boss test. Here's a boss test arc. Here's a test arc built with the system, which, believe it or not, it's actually incorrect. There's a lot of symbols and things that are missing to show the difference of things. But that's because we're still working on a lot of this. Like, um, a lot of the stuff back here does the stuff, all this stuff back here. Um, I have actually gone through the code and I've actually like learned um, both through w3schools.com, which is where I learned my JavaScript from, by the way. Both going there and talking with Grok. It basically asking questions like it's a teacher. Hey, find this on the internet, and when I don't understand something, I straight up tell it like I don't understand. So I look first on w3schools.com for what I'm looking for. Can't find what I'm looking for, or I can't understand it. I ask AI to help understand, help me understand. I know it's somewhere. I think it's like, um, oh, I'm on the wrong program. That's looking for, you guys can't see what Oh, I'm actually in a spot where I was. Yeah, I was just bug hunting, fixing bugs. So some of the stuff that's up in here, like the variables and how the stuff is being inserted into data arc region and things like that. Um, I've actually been working on those things and learning how that bit of code works or whatever, or how to manipulate or actually code that Python. So I am learning how to code Python. It's taking me like it. Python is a pain in my ass. It's always been. So I feel like it's taking forever, but we're actually getting a lot done. This is less than a week's worth of work, and I think it's like 4 or 5 days in total, maybe a work week. And I feel like I got a work week worth of work done. Like okay, here's the spot. So, for example, when you are building an enemy, let me show you what that looks like. Build it up. No, oh, that's right. I turned. Let me how do I how do we bring it up? Okay. So, for example, down here in the script generator, we're just gonna go ahead and hide the maps. But right here on the script generator, um, we can oh, I can't. What is my little mousey said I could. All right, so we can pick like an enemy or a boss or a mini boss. Now we can scroll in here. So also map location, group, or an NPC. And the ideal is like we can build individual entities that we want to spawn. And you can see they have a drop rate, so how often they drop things, and they have a spawn rate, meaning like well how often will they spawn in compared to all the other ones. And we don't have the spawn it because that's going to be done in the actual game engine side when I start building that. And that's going to be different for every game. So this is a set bit of information that you should be able to code into data arc. So, like for example, let's go ahead and fill out a little enemy form. Um, we have a blue pixel, um, and it's got a drop rate of like 55% because why not? Base enemy, not gonna have stuff in, but he's gonna spawn in like 90% of the time. We're gonna see a shitload of this guy. All right, and color blue, duh, right? Let's give him a um in this system near zero, like zero is just off, right? So one is like really good, and then anything after one is really bad. And so the ideal is that you can give it a base value of something large. And in the code, it would say, oh, um, like you got to multiply this by some form of decimal, and that will then create it either to be larger or smaller, and so that we can manipulate how we scale or grow every individual thing. For example, enemies scale backwards. You give them large values that go downward, and then like bosses have they have relatively small values that you want to make smaller, but there's a random chance it will get bigger. Like there needs to be a chance that you actually get slightly less more powerful enemies, because we work on a system where every time you kill a boss, the next boss is like new game plus boss. So it's not a matter of finishing the game to get the next harder boss. It's just defeat the boss, get a harder boss. You have this chance, because it's the percentage manipulation, that you might get an easier boss the next time. And so this value technique of one is large, one is small. For example, mini boss is relatively small compared to an enemy, but it's relatively large compared to a boss. This creates this natural dynamic where no matter where you're at with the player, you can scale your enemy, your boss, and your mini boss individually, independently, and on the fly. So we're going to give the value of 1999. That's not max value or anything. I can put like 3,200 characters there, or 32 characters. I don't know, it's a large number. Um, we just want to, we don't want to go that big. So texture, we're not even doing that yet. Basically, you would be able to say either like go like um, um, uh, blue pixel. Um, oh wait, blue pixel. Frost eyes, and you would have like a file. Maybe it's like frosteyes.png. So you would have a file, and it would look for that file. Oh, but say you don't have a file, and you're like, "Bruh, I need one made for me." You would do this, which would then say, "I need you to generate me this texture for this," and we're talking about like PNG texture mapping, so it's obviously like flat pictures and stuff. But you inject it, and it boom shows right inside. Says all right, and that's actually how like an enemy is defined. Now, one of the problems we're having here is there should be a comma to let the system know there's more. And so, for example, we're gonna go ahead and put a boss. Um, the boss, we're gonna do something kind of stupid, right? We're gonna go uh blue-eyed light dragoon. Yeah, I know it's supposed to be dragon, but we're going dragoon. And then the drop rate on this bad boy is 15. But he barely drops, no, 9. He almost never drops any. And the spawn rate of this motherfucker is, yeah, 15. That's where I wanted that. The health base is like 1, 2, 4, 5, 6, 7, 8, 12. Huge number. His defense base is just 600, a large number, relatively, right? And his attack base is going to be 330. Makes sense, right? And then, of course, we have to have white as a thing, and the value on this mother is going to be 9. Okay? 9. We're going to whoop ass. Whoop ass. Right? And then we're going to say, what was it? Give that. Oh, yeah, I know that's what that on purpose. We'll insert that in, and then we'll say that's the last thing that we want to add in um, with the script generator. Um, so, I mean, there are more scripts that I need to set up in this generator. Like, for example, we can say, I need a mandatory interaction that if the user, or actually, we have a spreadsheet thing over here, so I can say if Sarah, um, specifically, if Sarah touches, um, and we want, what is it? If Sarah touches an object, any object, Sarah. So if if and only if the active playing user, because there is um, multiplayer allowed. So there, if you just type in user, it's all and any user, including non-active users. So anybody from multiplayer section can be considered a user. But Sarah means specifically and only the active user can activate. All right. So when that user, let's say it's the host play, right? So when they um, touched an object, we're going to activate the boss. So it's going to be like a game of don't touch, don't activate boss. So everyone else has to do the work, right? So let's actually title that arc um, don't host no touch, host no touch. All right, and this is one of those where do we want to set an estimated time to finish, an estimated time to start, a hold time, short or long? Well, you know what? We want to do estimated time to finish. We want to give, hey, it takes approximately how long to finish this, and at the moment it's minutes, minutes. I think it's minutes, 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 seconds, seconds, and then micro, millisecond, millisecond, millisecond. We need to get something put in here to help explain that. So get working on that. But anyways, it goes. So we're gonna say it should take like um 15, 15 minutes. Um, we'll say 33 seconds and some random amount of milliseconds because they don't matter. And so it is a safe zone, a crawl zone, a fight zone, or one of these multiple mixtures, which I am working on how to figure out how to get those where they look better. That does not make sense to most people. But one of those mixes is like a safe and a safe, or a safe and a crawl, or a safe and a fight. So those little things. So you know what? We're gonna say this is a fight zone. Now we gotta have some kind of mix. I was made a mix too. I believe that's fight and crawl. So let's hope we can get that. Starting message when the users drop in. Boop. Agreed with this message that says, "Welcome to your doom." You know, little inversion reference there. So, do we want a map? Let's not directly attach this to a map. Let's allow this to be applied to any map. So we're going to leave it open. That would actually allow us to either generate or import a map specific to this story arc line. And we can put more things into the story arc line if we really want it. Because remember, we want to do something with Sarah Touch's object. What was it that we needed to do? That's right. We need that to actually activate. Um, is it in our, we have a thing in boss? Let's see, no, but we can. The boss has been defined. Therefore, we can reference that definition. We can say, oh wait, say, um, blue-eyed dragoon, and then we're gonna say that causes specifically spawn. We have a thing in here for spawn. Should be at I don't know. I don't know. But you know what we can do? We can say warp in, and we're gonna give it a location. Um, yeah, warp in at this location, which we want to make it non-specific but somewhat specific. Sarah. So in this case, I could have done, um, I could have gone like this, and I could have named the symbol. So I could have been like that symbol, and there's more than one, which means it could be one of those two randomly. Um, we don't have a way to set probable odd on which way to do. We could have gone and said that we need it to be no, it's this and then one. So we could have done that, which would say no, no, we had to be zero. I want to use the very first one that appears in the map. The way that works, it goes top left, goes all the way down to the edge of the map, and then it goes up and there's the next line. So that's how you could set that order. So you'd have to know, is it the first one, the second one, which one is it going to appear first, and that would allow you to set that setup. So this is a non-time specific, but we have some time specific elements in here to create a formal time complex or strategy, because it's not direct one. And we got all these stupid little things set up that allow you to really put in a full storyline, put in enemy, set in force activation, set in traps, set in discovery options, all sorts of different little things that you can basically inset inside the arc that then can be applied. For example, this one's going to be able to be applied to any. Now, I do want to set a way to end this, so we're going to say, like, I know we got more data phrases we're going to have to build out and stuff, but some of the stuff that you can do here, for example, there's kill, there's death, there's squash. So, kill, I do believe, is when a user of some kind kills enemy. Say when uh, when kill, we'll say it like this. I don't want killing itself. So user kill blue-eyed white dragon. Okay. Then let's just import, and then here we'll go and we'll import a new, say, then we'll, and so I don't have a credit roll or anything like that. So, for example, that would technically work, should work. That will allow you to have these blue pixels, like a shitload of them. You'll have this blue-eyed white dragon boss that comes in barely, rarely, sometimes if you're lucky, and hopefully we get a Yu-Gi-Oh! Inspired texture. When the active player touches any object, which, oh, that's right, there's no objects in the game. So an object. Rock. Make it a rock with a 99% drop rate, and 99%, no, 81, 81 chances you're gonna run it, that you're gonna have this. Yeah. All right. And yeah, let's do texture. It's a rock. That's generate. That's why we have specific generate call and import call, so that way you can actually put things to the AI and say, hey, look, I need you to generate from this meme. It's a rock! Because it's the, it's not just the boulder, it's a rock! Because apparently the pioneers, they used rocks to get everywhere. So, super important. And confirmation message, because this was all about, we need to give them a way to confirm something happened, which we have in there. We have a series of events. So this might actually happen. So this confirmation message, it's going to be possible to happen if the player hits an object, if they actually warp out. Leaving the zone will cause the confirmation message. So let's make it a little bit of both. Touching the rock causes the dragon. Hitting the dragon will cause the message again. We need it to work both times. So let's think about this. Now I could there is a way to go in and say like there's a way to set the confirmation message in a manner where it only activates when you warp out, like or whatever. I also could have set it to um, it be the thing that happens immediately after the warp. I don't have the data phrases over there yet for it, so that this is the roadkill. Not what he was. All right, so then we have all these options over here, which we also have some of them. And so here we're going to go ahead and save the arc. We're going to go back to show maps, and then we're going to go ahead and attach this. Oh, we didn't save it. No, 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 no. No, 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 no. So the most recent update caused a major issue. This button is not properly working, which what it's supposed to do, it's supposed to take all this and save it up here as an arc. For example, if we load in, would you like to save? Yes, I do. Save the map as a dictionary. Let's save it as a dictionary. Let's go into dictionaries and say messed up did, and it will save it right here. Let's see, file type mapd. We're going to go ahead and hit save. Now we can actually open up what I was wanting to open up, which different dictionary. And so you can see here, this one has an arc. And so I'm going to go ahead and hit load, see if messed up on string. No, I really didn't save it. Hit save, nothing happens. Here, back to this one, arc was so another bug. But that's the whole point of doing this. Like you never know until you actually press all the buttons, you do all the stupid stuff. And I thought, like I've done this test, like I know all these apply. I know this to the grid works. Done extensive testing there. I know that most of the stuff normally does show up where it's supposed to. Up until this update, I haven't had issues with the saving protocol, but I had just made a major change to the saving protocol to get these windows to work more proper. So that might have messed something up, and I just gotta check it. So this is the point, right? Like whenever you're doing this stuff, is you'll have something change that has nothing to do with what breaks later, and that's because you have an AI or you are not the one going in your. So it's super easy for the AI to go stuff like, well, if I take this part out, I'll have room to fit this within the amount of lines I'm allowed to show this. And that's one of the reasons why I pay for like Super Grok. I hate it. Um, if I don't, it will keep everything like under 700. And I don't know Python, and it's been like when you start getting to like 14 code, or you start having a series of multiple functions or functions nested in functions and stuff, get to a point where it's like making subtle changes are just difficult to know where to look, how to do if you don't know it. And so that makes it a very good complication, blah, blah, blah. And your best bet is I do stupid stuff all the time where I'm like, yeah, break it down to me. I still don't understand. Um, uh, go through one. So, this is how I'm starting off the message. I have this Python program I'm working on, blah, 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 blah. So, information that this is part of something, but it's not all there. Working on one little section of this is the blah, blah, blah. It's a Python program. I'm going to try every button. I ended up not trying like all of them. I only did the one on the top bar. And I did this again for like the grid buttons, the phrases or whatever, so I knew all of those worked. Um, and so that's kind of like one of the things you do is you're basically like, I'm addressing to it that I'm about to do a bunch of stuff. I've already done all the stuff, right? Um, but I'm talking to it as if I'm in the middle. And then, like for example, I tell it I'm about to give you code, look for this, and then I kind of don't tell it what we're gonna do. I know it's gonna forget, so I just inform it of how to talk to me, so I know that it's on the same page as me, which is we're using special phrases at the end of things. So you'll see ready for the first section. I give them a section, and it's a good amount of code, right? A few hundred lines. And I think I'm doing like 5 or 6. Ready for the next section, and so because I know what they're looking for as the end of the program, they don't have to guess or anything. See the let me know what problems you need corrected safely without destroying what we created. When they're able to repeat the things you're telling it part of the goal, it's easier to then state this in here and it understand it's a goal without you having to explicitly say this is goal. It's gonna go, oh, we said this earlier. Scout's gonna say it's gonna be when it's thinking. It's not gonna say user. It's gonna say the user gave me in like this prompt, and then it's gonna say we said blah blah blah, and it because it phrased it back to us in a semi-natural presentation from its word. Um, and that's because this was a goal. It was a goal that when it saw this little bit of code up here, goal was to then I believe I told it to uh, absorb all the information, understand how the functions work, simulate some of the stuff, um, basically do analysis on it. And while it was doing all that, there was times where it would notice bugs and errors and things that are not bugs and errors. They were things that like, oh, well, you don't know all the code yet, so just look at it and you'll see it. And then later on, in one of the other ones, it would just be like, oh, there's this. Oh, no, that fixes it. It would just kind of like pass by. It would quickly pass by itself, realizing, oh, no, that fixed the thing I'm bitching about. And so if you was like watching it and letting that influence what you say next to it, it'd be really complicated. The ideal is that when you give the AI goals, you have to meet them. Not meeting those goals can cause problems where it wants to reset back to that point, no matter how much further you've gotten back at any point in time later on. It'll say random, oh, we're gonna roll back, and you'll be stuck there. You won't be able to get out of that. And the reason of that is because there's a goal that it has to, and it's been taught to be completion oriented. That's what it's doing. Um, so as we go, and you see, I give a lot of information, a lot of stuff predetermined, pre-set up. I'm this type of stuff that I'm allowing the AI to figure out is like stuff I literally don't know. Like, how do you code this in Python? You know, and so then we get some of that information. You see, like things like this, it misinterpreted what I asked. I said, here's all this information, reference it somehow. We're going to save these as files. Because I said somehow, this is somehow. That's a whole lot of extra bullcrap for no reason. And why are you going to set that like that? Basically, what it would do, because it had this like this, if it came across a user who didn't have these files already on the computer, the program would generate it for you. It would generate you the file on the spot. Okay? The file is being provided with the program. It forgot it was in a goal. There's no goal for this stuff. Now, talking to it, there's a goal for the data structure. There's a goal to keep this structure thing. So remember earlier, I moved a bunch of stuff out of the way. I did stuff. See what happened. Unnamed team map still there? Try that again. Try that again. And here, where'd it go? Where'd that data map go? Ah, there it is, back where it belongs. It it literally, like like AI accidentally set up the program to clean itself. That we can now, if we want in the future, force it to keep only one version of itself. Things like that. Rid of all this extra crap that I only keep here because it's me associating what I need to. When it goes on a GitHub or whatever, it'll look like that. Let me show you what I mean by that. Because if we pull out this drawer, go to history, um, one, we go down far enough, we'll see this data walk. Okay, did this stuff with data walk. See what's going on inside of it. Upgrading character move. All these different street. We have all these things. So, and the file for what I'm just showing you, this stuff right here. Data walk. So this one that archive list. Wow, not allowed to view GitHub again. It doesn't like it when I'm not logged in because it doesn't like. Okay. Um. So if we right here, data walk. So in data walk we can see looks fairly nice. Um. Fairly well set up. It's got some bugs. It's got some issues. Um. It's it's kind of hitting a wall with uh security policy, trying to get it to where it has full higher about like dangerous. And if we look, we got like two major versions that are available right now. These means both of these are current versions. So Datawalk 2, Datawalk 3 are so vastly different that I don't think play 2 and then you play 3, you'll be like, well, yeah, that's the same. Not even the same. Because I believe Datawalk 2 still displays all folders and files, and if it's unable to access it, if able to see it, it puts that information controlled for you still, so it feels much like there. There's actually less there. Um, and then 3 technically works more like it should. Has a lot more of the functions and has like I'll end up showing this here in a second. But if we go to archive and we say, well, how many versions? There's only one other active version, which if you play Data Walk 1, play Data Walk 2, play Data Walk 3, they are all completely versions. So Data Walk 1, Data Walk 2, the difference is not as vast as the differences. So let's go ahead and let's let's pull out the most recent data. What version we? Here it is. I'm gonna go ahead and use the keyboard. We need that. Oh, I accidentally on building. So I have a custom set color scheme. I have some boxes that are custom colored, specific man. Here to spot them out different. Snap. And you can see there's a bunch of stuff on the thing. Some of these don't work. Like Z doesn't work. So if I click Z, so then if we hit escape, and then we turn off, but Z is supposed to toggle on. Now we can naturally fly by looking down, and there's a dead zone, so I can look around down onto level. The words move based on my world. Um, I did try to do a thing where when we get in at certain ones, it would rise, and that was so that way we could get the name, and that ended up causing a bunch of problems, and you needed an actual GP. I don't really have. So we have this home finder called beacon shows up, but I'm not. I would like for it to get bigger as we get further away. It does get darker, more visible as we get like we hit a certain point. Get less like a natural slow decrease size. I want. But we have and again, this is another one of those. It's like 98% vibe code, and I've been learning Python through doing this, and I can, yeah. For example, I just left clicked on document. Now we're in my document folder for what we can see. This was generated on the fly. It literally checked contents of this folder just now, completely on the fly. So there's recover monitor script. There's my next steps for monitors. That's another script. That's for like getting my monitors to successfully connect and work properly with a 3-monitor setup on Linux. Stream setup stuff. This is one of my big files, of course. That's got system mocap. Sorry, I was looking at the wrong ICS and some programs, web apps. Ooh, we got a bunch of web apps right. Ooh, going to hatch out. Ooh, ICS. There is ICS again. Do a diascope. Ooh, yeah, hash key cutter. It says game clock. That's right. Oh yeah, I forgot. I made a entire in JavaScript, entire fake simulated global scenario. So it simulates sun, moon, weather, some constellations, and a couple of phasars that you can actually see from in order like in a fake environment. So it's not a real world or anything, but it's able to track all this information and calendar and time and all this stuff in a natural setting with it. It's a simulated. It's fully simulated. You can even adjust how quickly or how slow time actually works. So it's really, really neat. And so now I'm in a thing. Oh man, what do I do now? I just look down and go back, click, and I can go back. Fuck yeah, man. Heck yeah. At any point in time, I can just look out, right click, pull out this, right? Oh, neat. Neat. Go into Explorer. So when we return, it puts us back in the middle again for this kind of stuff. Now, um, if we look around, um, yeah, we're just gonna find more and more because these are programs that I have, right? So we're gonna find more and more of these as we keep looking around. Now, let's go ahead and exit. Um, no, let's not save our last location. And I said, yeah, no. Okay, so we looked at it, we understand, blah blah blah. It works. It does its thing. Okay, cool, cool. So the vibe coding stuff, like this has some security issue things in it. Where like for example, some of the code isn't actually secure, meaning like it could be manipulated or messed with while I'm playing it. Um, but we are uninvasively, like we're not doing any kind of invasive checks or anything. All the types of checks we're doing are allowed by the operating system. The only reason we're coming across problems is I'm purposely not elevating permissions to give it more permissions, able to see more. That would allow it to cause more havoc or cause harm. And even at the moment, the thing that we were using, when I right click on buildings, I don't think we ever, I think I pointed that out real fast. Um, so when we like right click on buildings, it enters an alt menu. And you see, like, as long as I'm near the thing, I'm in a protected bubble that allows me to do a bunch of little things. That, as you can see, we are like scrolling around these options to deselect, close, change the color. We can straight up enter it, open it up in my operating system, copy, cut, or delete. And turn this into a beacon, so we can add this to a beacon list. For example, you saw I tried to set to the beacon, caused an issue. I wanted to. So, and then because it caused an issue, we locked it down. So we're gonna hit. Oh, that's beacons, buildings, list for beacons. We have these automated spots. So I can click here, right, and it would just send me there. Now we're there. We're here. I'm at that beacon. I said the beacon earlier while we were playing. Like I think I was doing a live recording for like something like that. Said it. Now we have it. Now I can just go back home. I had said that is a beacon. Oh, now I'm back. Just like that. Done. Cool. I can go in here and I can hit the index key, so and I can see everything on the field, and I can change the way the order stuff is done. So right now, let's set it to age. Now let's go to size. Yeah, let's go back and now I'm back. You see everything's so it's actually dynamically, um, everything's dynamically set based on certain things. Like for example, everything on that case, I set it to the size, right? So the things that are bigger size, whatever, smaller in size, are closer to. And see here, this is the actual proper like right click. So this is a global right click menu. This will allow me to change global position. Allow me to remove the beacon out of this globe. I can also exit out of here. Done. And I could have even like looked at my shadow and done it again, which right now it's an orb. Back into a shadow. I'm trying to make it a glowing shadow. Um, so you can right click on your shadow and get like personal, like your right click ultimate. And so there's like these different things that we have that like like, like the in world in game pop in menu. Like the pop in menu where it was like the that's around the object. Like I fought to get this thing to do what I wanted. And there's another one that I wanted to do where it would put a ring that moved around with you and stuff, but it couldn't figure out how to do that. And it's probably because I don't understand how to explain it very well. But it's basically like you have a view cone. So we set it to a point in based on the field of distance. So that way all the options when it spirals around it will sit with inside the bounds of the screen. And then as the player moves around physically in the world, it would allow, like when you turn left or right, the thing would rotate left or right. So this would allow you to player to physically move around. And I thought, oh, this would make a if I could get this to work, pop in menu that's somewhat interactive, like you could actually turn the screen like so there's a lot of games now they don't want go into a menu that doesn't pause the games. Now imagine a menu screen that's fully inset in your game, pops into the world, kind of like you guys saw with the Expedition, but it's live. It's no longer frozen. It's live. Okay. And in order to rummage through some of the stuff, I could move my mouse, or I could just turn my character and not have to move my mouse, still be shooting or attacking or whatever it is I need to do, and then also be able to click on that object in my view. It's like an actual AR within a 3D scenario, and I'm probably the first person to have it published on GitHub, and it's super like low end, but it works. Python, um, but it's slowly working. It's slowly getting there, and that's the big thing about this is that whenever you're doing anything with uh, code specifically, there's some amount of length of time, blah blah. But let's go ahead and like let's go and view something I've done. So we were looking at some of these, remember, web apps, Hashwell. Um, so actually, Hashwell is probably a pretty damn good example. Um, this is another one where I had code and I was like, yeah, I want this written. Why is it not? I want this written in Python and had JavaScript transmuted into Python, and then I used Grok to continue to help me build onto it now that it's in Python. This is a program called Hashwell. Um, this is a unique type of system that allows you to bloom. Well, this allows you to use like a series of bloom filters and filter checking systems with hashes without opening or like we're just basically manipulating the hash to get data out of it in a manner that is safe. That allows me to have like a true privately or publicly private um, scenario of allowing. So like we can have a database that's publicly online that's actually private. Um, that you can't just like you can pull out data you know about. But you can't just do anything with that about. You actually got to know something. So you got to be a part of the secret, and that's somewhat similar to stuff we already got. Blah blah blah. Just a little bit more. So let me see. Um, um, it used to be set up where I could just like click open. But it's been a while since I've even messed with it. This one isn't in JavaScript. I would know how to open it. Oh, there's different Hashwell, so that might have been in the web apps. I'm sure this is not going to work just because stuff. Let's try. All right. Then we know we'll load stuff. Those are this one for sure. Oh, so this is fully simulated. Nothing about this is real. All of that is being produced. Fine. This is QRs don't work. Um, so the QRs used to be provided for free by Google, then cut out that I think had. But you see, we have custom labels over here. We have custom labels, progress into the day, progress to the hour, progress to the minute. So you can now know what time it is. Here's the superposition. Here's the I don't know. Or one's day of the month. One's day in the month. One is month in the, or day in the year. Here's a global weather bubble. So it's kind of like the idea of like the center of the dot is closer to edges are further away. Here is your superposition inside the month. This is the day of the month cycle thing. Then we can click here to actually get data. There's a bunch of there's supposed to be a bunch of keywords actually, but as you can see, there's shadows that are popping up and stuff. The shadows are estimated real world shadow positions, so that's about where the shadows should be. As you can see, basically the shadows are right underneath everybody right now. So all the colors on the screen are generated by some algorithm that is completely based on the epoch at the current millisecond. And that includes like all this gradual change represent what it looks like outside, like the sky and stuff. But even that is being determined live on. So let's look at everything. So basically, you can see exactly my time. I mean, I say that, but it's not actually off. Um, but it's very close. It's very close. You can see I got a superposition. You can see what year it is, the epoch year, the epoch length. So these are the numbers that in epoch. The month, so December is 20. Oh, okay, cool. Um, is nice. We can see the expected sunrise is 8 in the morning. Well, actually, like yeah, no, that's like 8 and 80th. That's 80th percent of the hour, and then the 21st hour and the 70th percent in an hour is expected to start seeing sunset. And then so we have a sun and a moon, and you can see they're pretty close to each other. Where I'm at. Then we have month to year superposition, the natural year superposition, um, me position to the year, so we have position um, technically in all times, and then we have a so here's the superposition. Um, here is the current superposition right now to the epoch. So you'll notice uh, uh you'll notice it's like a pattern. And it's similar pattern to background radiation. And so here are the Urums. These are all being generated on the fly. This is color. Um, this is color. Basically, each one of these represents some color. Dead serious. And then we have the links. The Urum link allows us to control max length of color coordinations. Then we have various epoch time slices. This is the epoch slice in different ways. So we can gain various manipulable numbers that we use, for example, build all the colors. Here's the current epoch. Hour, fourth hour, the eighth hour, seconds, milliseconds, the reverse seconds, the reversed minutes, the reversed quarter hour and sixth hour, reversed hours, the not today date, days in the month. That stuff. Supposed to actually tell me how many. So the second grade readable time and the second grade reverse time. Now that doesn't mean second grade does not refer to elementary school. It actually refers to like a parallel plane of existence. So there used to be this belief that the Earth exists upon a certain plane called the first grade. Now there's a second grade that intersects with us, but not at our center point, which is how we have a North Pole. Third one, third grade, is our South Pole. And because those grades don't intersect directly in the same spot in the same way, it creates the axis, tilt, all this other stupid stuff. This is like they even like the grade thing even can explain why the poles move because the grades are moving independently from each other, which causes a superposition between two points that are pinning in these three planes. Meaning, like our main grade is like the center, the other two are not. They're above and below it, causing these issues, and they're actually touching really far away from super. So then that creates like the third right time percentage is like how I believe it's how far away are we from the third right in time. We're not that far away. Um, Various galactic hours. So these are various time or hours in various places in galaxy. I believe this is. Um, is it AM or PM? What does that mean? The actual basics for hashing of the current time right now, the day progression, the hour progression, the approximate shadow relative to shadow information. Here is the quantum gradient creates gradient scale that we see in the background, and then the approximate global average temperature is this color right here, and with a 29% spread, everybody else it's approximately. Here is what the color things. So if, like, for example, it says possible time-based weather colors. These are all colors based on time. There's a lot more color there than what we can see. So there's like 41, 348 you don't really see. And then this big long 1, 2, 9, 4, 1, 3, 9 also don't see. All these are the numbers you kind of do see. And it creates this really super scale. And when you wrap this on a globe in a certain way, like basically the center of this is the, and one of these is the North Pole, and one of these is the South Pole, you very quickly start to see how things are distributed semi evenly on the Earth, but not quite. It actually favors actually more towards the center. And that's basically just an algorithm I made that makes this right here. And even like this weather thing that move labels. Let's hide the data. And if we want to learn more, we can click learn more. And it will actually kind of explain to us what is this, what are we reading. There's a development paper. I do believe it's trying to pull from like for example, relative positions and time zones, little things, right? But I like this not date and time. So this is the not date, not today. It is not currently 1900th year, um, 7th day of the 71st month. And it's currently not the 89th hour of the 90th minute of the second. So I kind of like that. It's not these. Um, okay, so here is what it's saying. The global average temperature is between 16 degrees Celsius, 61 degrees Fahrenheit. And so right now, there's a ton of people that could be watching this that some of you or most of you probably going, bro, it's cold. But if if you look at the bubble, this one right. Oh, well, right. I made that better than I thought. So a large portion of this bubble is cold, and even like here in the sides, it's cold. What it's showing you is it's an even distribution of the globe. So part of this, like the top half is the top half, bottom half is the bottom half, and it's just kind of showing you that distribution, and it's showing you that where the heat is very centralized. It's not spread out. The cold is what's really spread out. I remember earlier we saw it was a 29% spread. Still don't know if that 29% spread is for the cold or for the hot. I don't know. And then if you see this other bubble over here, this is a time bubble based on like us with the month, something like that. So kind of cool. And it does see we're seeing some kind of shadow change. So it's saying that shadows are changing. See some of that going on, and 100% just like generated on the fly, blah blah blah, right? So we're gonna pull up one more thing that I've like actually coded by hand. I wrote a lot of these. Well, I'm gonna pull up one where I wrote everything. I even wrote the paper. Like I got a paper. I'll show it to you. Everything about this, all me, all me, and I say it like that because I it's kind of like my baby. One of these programs that I did. Super glad I did. It's a secure text element with its own encoding method that is as good as encrypting data without encrypting. Here's what I said. You guys have not a clue what I said. See if it works. Yeah, that's what I said. Orange is a color. No detected errors. Look at that. Now, is it perfect? No, not yet. No, it's not perfect. I have a lot of problems. But it works like it's actually the amount of times it works compared to not working, and bigger and bigger and bigger, better and better and better with it. That's right here. So this is superposition text using quantum manipulated dynamic deterministic compression to condition text with verifying data. That's verifying data. We are inflating data to verify what's actually going on in a manner that actually makes it smaller after this by the binary. And I go through and explain it all. I have a full on paper for it and stuff like that. I go um, code. I'm just used to clicking on it. We have the PDF. Come read. It's got a lot of information here, visuals like that. Break it down simple as I can explain. There's quite a bit here now. Text is kind of large because I'm old, but it's all legit. The tables, I think this table has actually been changed since then, and I've also come up with a dynamic, deterministic way to actually handle, to be able to handle collisions. We have two of these exact same output or whatever, and so once I get that working properly, like you'll be able to mess this up however you want. It'll work. Um, And so it's doing quite a bit of self-correcting. Like every step of this process, it's basically trying to correct itself. Sometimes that kind of messes us up. Sometimes it's really good. But I've even created specialized checks and things that have never existed before that are just basic math. Well, I say basic, but it's like complex series of mathematics to ensure it. For example, a spherical parallelogram check is why you just trust multiple parity checks when you verify a parity check. One of the key bits of information we want to supersede one of our data sets is a number, which is the derivative of the algorithmic data based on wrapping parallelogram around a sphere. That's right. You can wrap a parallelogram around a sphere based on a certain set of information between the two objects, which then, when you do this, you can now use it to verify it works by one number. So we will build a parallelogram in a sphere based on the length of the image. We'll form a check based on what we could obtain after detangling. But we also base parts of the parallelogram sphere data points off the number of internal loops that need to be made for the completion of the rebuilding of the graph, as well as the sum, but the combination. So, for example, for the example formulas, we're only going to be using the JavaScript math notations. So here is the starting variables. That's what we need to start with. See that there is a 18 loop limit counter set up on this input, and then we find these parts of the parallelogram, and we find these parts of the sphere, and then from that at this point we should have a parallelogram and a sphere with values that should be capable of being mapped in a 3D space that would allow the parallelogram to wrap around the sphere to touch itself but not overlap itself, taking the magic number or by finding the difference between the parallelogram's volume and the sphere's volume, dropping any negative sign you might receive, have up to two different numbers that can be rediscovered once you are able to map the objects to 17. This is one of these checks. Like, this is a check that we do. We build this at the very end, and the way we're able to verify that something's correctly is there's a point in this thing where in decoding there's two major points in the code. Okay, so when decoding, you're doing the last half first. So when it's time to do the first half last, we do this check. Okay, and it will tell us if we've already fucked up before we do the next step, which is very complicated. So it's very work intensive. So it's important to have it checked right before that to make sure you're not about to fuck something up before you a lot of work to do something. So then we have this super simple pattern-based token swap system, which is so quick and easy that it happens within seconds in wrapping the layer. It's like super quick. Um, and we can see that it's designed to work in a specific way. It works on the superpositioning of certain types of data against other things. So that way, we super simple token position things that actually are pointers, and then we can actually do that in a different way to create a different set of pointers. So we can have pointers that tell us to look at one of our lookup tables that we use coding and decoding process, or can look at part of the string for the data. Like it's already in the string, we just look, oh, it's over there, just grab it. And this is all done while it's completely encoded, while we're not looking actually at the data, while we've already stripped out like 90% of the real information. And the only things left is like little bits of information, pointers, and verifying data points. So we're getting to a point now at this point in the stage where there's almost no real data left. And then we do a quantum entangling and compression on this. So now we're going to remove approximately 97% of all the possible data that could be, and we're going to be able to bring it back up. Like, %97 of the data is gone, right? Orange is still a color. And it's because things like this is the pointer where it can point to itself, point a different part of the string, and say, oh, there it is over there. And This is super quick and easy, and it is a type of proof of work that you can add onto some form of proof method that just allows you to express naturally anything. Anything that has patterns, we can, um, and they're pretty simple. Here's a basic token map, and it actually explains how they both differ. Where in the array, what does the token begin with? Which array, or how long is that token? One character bit or one bit only repeats repeats this number of times. So it's this by this optional. SPX tokens is where in the array and which array. But quantum entanglement tokens or quantum entanglement compression tokens are where does this token begin at? How long is the token? The exact same token set. And this goes on. We're starting to get into proof. So we're actually getting that we have a reference example. So we just gave an example. You can realize where you. So like here we go. We're actually going to give a real world example of hello world. This is what we inputted. That's input length of 11. Input sum is now 37. So we know sum is 37. We have a loop point. 1 times 18 over 18 characters. We loop through. We have a macro loop 2. The example input macro loop addition. So it's length module 9. Full action counter is 1.5. So the example full action counter, that's how we got that number. It's the average sum of the loop point and the macro loop point. Here is the physical node output. So this is in regular D. This is called font is EE2E font. Okay? So it's an end-to-end. It's in encoding into end font. Coding into font. And it's called D&D regular.otf. It is technically known as node. That's the one we had it pulled up. We say something, looks like that. Looks like little node maps, what they represent, what they're made. So we create a faux binary state. So we have these 4 data rails that we're looking at right here, and we have this index. So this index is kind of the secret sauce, right? And it's used on everything, so it's not actually secret. But the way we use this index is secret. So we have this full grid, which you can see the index is applied to back to it. But this creates a relationship between the data and the index that we can physically see. It's a pattern that we can, like, that any computer or any human possible. Look with your eyes, you can see patterns there, and there's difference between patterns. It's obvious. Now, we go to shifting data. We're going to now take all the data on the rails, and we're going to shift them over in a manner so now they have nothing to do with the data. Very first bit, one of these rails, is the only real data you're ever going to distribute, ever. 4 bits of real data. And they're not even an entire piece of data. They're representational sections. Representations of sections of data. So it's not even real data that we're moving. The 3% of data we move over is literally fake. It represents the real data, which gives us this full grid. Then we build this parallelogram, build the sphere, get our magic number, we get a chain weight. We now make pattern-based tokens. These are the tokens that were used. These are the ones that were used. I'll show you later all the ones used within like 13 seconds or 13 milliseconds. And then these are the used quantum tokens. We only need exactly 3 quantum tokens to be able to compress this. Nice. We have the hash graph, compressed hash graph, but a quantumly compressed graph or hash. Slowly gets smaller. So if we take the input uninterrupted binary, it is a total length of 88. If we take the final quantum output, 73. We take the uninterrupted output info binary with its index, 67. No matter what you do, my method makes the output smaller, regardless. Regardless. This means that my faux binary system is a smaller system than standard binary, but requires an index, while standard binary requires no. But even with the index, it's still small. I even have appendixes. I have information, all the right links. I give it to you all. I give you my reference images. I'm handmade these for you guys. This actually explains the process right here. This entire thing process. Um, I show you guys my compounding Hamming code and how this system is compounding the data as we're obtaining it. Here are all the quantum tokens generated for this example. These were all the possible tokens I could have used. Approximately 1,271 sets of tokens were produced that could have been used to reduce the general font size, to reduce the general. My system's so fucking good. It was able to determine that it only needed 3 out of the quantum token. Out of all these tokens, it needed 3. And it produced this faster than most supercomputers could start up on a binary machine multiple years. So obviously, coding my hand, I can do some good shit. I can make some shit that will make you not believe in things. I can create, produce in JavaScript that I have been told is impossible to do when I was a kid. The thing that started me on this faux binary thing, because I was told that cannot exist. There cannot be a fake binary or fake quantum system, because quantum mechanics is based on something real, something that's like um, only exists in nature. And I kept going, but it's fake. Quantum mechanics is not real, it's an observation. Well, I'm proving it day by day, slowly. I'm working on proving it. Now, here soon, I believe I will be able to get to a point with vibe coding where I may be able to actually one day, like, um, be able to produce code this in quality of whatever, because it's not super great. It's just semi, like, it does a lot of work. Some of it's not super secure. It like the one we saw that's supposed to be secure is, but like for example, here is my first faux quantum paper thing. This came out 5 years ago. It took me 10 years to figure this out, and this is an actual program. What can this do right now? It can build zero knowledge proofs with low tech. It can build user specific binary codes. It can determine atomic value of input. It can build corresponding binary field based on user core. And it can define a base 64 methodology for binary square and base 64 signatures of the built binary core. Perform first wave field mining non-algorithmic logical comparison mining. Oh, wait a minute. 5 years ago, I was doing non-algorithmic logical comparison mining, and now with SPX, we have exactly algorithmic logical comparison. What a huge difference I did in 5 years. And so, I mean, like, just like, and if we come in here and we say, where's that? Here. I'm sure I have it installed. Uh, coded. Faux qubits. We're gonna make fake quantum bits. We input here. Hello world. We're gonna put in a secret. Hi. Hey, go changing your number now. I see. Here's our non-algorithmic, logically determined mind data. We have a binary core. We can put that into a binary square or a binary field. Much larger than binary core. The binary square is binary core. So we take that square and we expand it to get a field. Nice. Green line on top of that. You can see we got here is the field. This is the new stuff. Entangling not yet available. What's this? Well, that is a hash. That is this. Bang. Bang. Here's a signature of our session. Going to the basics before we're decoding a field. It what am I doing? Hey, for Guru is actually down. That's not expect that to be. So you can see that that signature actually contains all of the data, including the programmable sections and that. Like it's giving us quite a bit of. Um, and it was written 5 years ago on a phone, cell phone. You see this uses resources. We have every three resources is where I learned JavaScript. Is where I'm learning Python. Oh no, my bad. I read that wrong. W3. That's AC to hex. I read that wrong. One of my major resources I use. I'm going to use again for Python. That popped up. I don't know why I just didn't go down. Right here. This is where I learned JavaScript. Right here. This is where I plan on learning Python. Um, this is where I learned quite a bit of my HTML. Although I started learning HTML before the site, before I even knew it. So, and then even like just like okay, we're having fun, we're doing stuff. I do have some like serious code. This was vibe coded and stuff like this. So vibe coding has gone to a point where it is doing stuff, right? People are doing stuff with it. They are making stuff. But as long as you're not needing to rely on the program to have secure elements, you'll be able to do whatever you really want to do. The second, you need to start having secure elements. Well, uh, first of all, you're going to have an AI that runs locally. No non-local AI is allowed to write secure code elements. And that is like a policy that prevents lawsuits, because it's already happened. And that's because like malware developers and stuff, or people making malware on accident, all sorts of. So there are reasons and stuff why, like for example, um, when I was having problems with data walk, why did I have one version where like everything on the directory would show up, everything, but like I couldn't read what things were titled half the time, find out how much stuff, and the program would get bogged down, locked up, trying to do walk, which is just like looking at stuff, and it came down to like 2 points. Um, the first thing is Python probably not the best one to deal with security. Um, Normally, when you deal with Python, because Python has the ability to execute code in ways that, like, two things can be. You can do two actions that, upon the second action, a third action has been done. And so it's this complex scenario where you decide subscripts forming actions with other scripts, or one script is multiple things that, like, by the time your system even notices it's too late, or it's not able to see it. And so you get these little problems with Python in general. And when you do Rust, you're gonna have something similar, but Rust is a little more secure. But it's still not secure. So yeah, been getting some stuff done or whatever. We're getting further down. I found errors say, um, I'm gonna go through basically push more buttons and write down everything that I see that failed, and I'll get it corrected. Um, I used to want to try to put, oh, in a week I'll be, in a day I'll be, and I stopped doing that with vibe coding. Like when I was actually coding stuff, I would do that, and it almost never worked anyways. But every so often, you would be like, "Oh yeah, I'm gonna do this today," and I would do it. And those were like, I was always hoping for more, but I didn't get more of them, less of them. So, um, a lot of people who they're looking at vibe coding, they don't want to learn a new language. They want to just produce something they wish to gain from it immediately. And that really is the people who are winning in vibe coding, as sad as it is, because they're producing something quickly, and then them person are able to sell that, and that makes this huge dynamic difference, because with vibe coding, you're stuck paying this cost all the time. For example, if I wanted to just produce one of the outputs that I look like, go to the more when I so we did the whole thing like I said last time. Give it the code, and it runs the code, and then all right. See here it says like thought for 7 seconds. I think one before that said 21 seconds. Sometimes the thoughts are short. So I gave it all that code, right, in pieces, and I think out of all that, it probably took less than a minute of processing time. But the amount of processing, the amount of computation that went down, well, several thousand lines of code, probably closer to 500,000 lines of text. And if I was to try to just give that to an AI to learn, to be able to then like look through the code and point out what things I would need a computer like if I had just the computer I have right now, which is a like 5 or 6 year old computer, it's running 2070, it's 7. Um, I'm lucky I got a lot of high gigabyte RAM years ago, so I got 640 RAM. But I would still need 60, 70 of these probably to be able to produce this same. Let me know the problems you need corrected for it to be produce this output. Tell me I'm ready for my next input, knowing that it had looked through all my code, simulated some of it, um, is able to identify parts of it, what it means, things like that. Just getting to that point, I would need 60 or 70 of these, and I thought I'd spend like close to a day or a week, somewhere in that range, 1 day to a week, for it to then get to this point, and then I would give it all this, right? This is what I actually want changed, right? I thought for 1 minute and 22 seconds. And I'm saying less than 1 minute's worth of time was like up to a week's worth of my, like on me, what it would take. Well, then imagine what nearly 2 minutes is going to have to force you. It's a lot more going on. And like we're trying to look at like the thoughts now, right? We're looking at thoughts. So we can see that it's the thought process for some of the stuff probably, you know, actually, no, this is the very last thing that we. Um, yeah, this was actually just the very last set of thoughts I had. And it's still, like auto start selector tool, blah 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 blah. Not that bad. Still figuring it out stuff. But it's you look at its thoughts. It's really pinpointing specifics about the program without me telling it specifics. The auto start select a tool on program. That's something I multi select shows shared properties only applies changes. It's I just told it that basically I told it what it was doing wrong. I didn't tell it what it was doing, and it implied what was going on based off of that. How to save map stuff in a specific array, so like the array thing supposed to be different. It's not. The multi-select system again, it's parsing that property. Um, and now it's learning to cut stuff out of itself, like got the dots and C's and stuff like that. So I mean, it's quite a bit going on background that I personally would never be match um, in power and time and all that. If by running my own local AI, I mean me personally doing it. Um, like for example, this one is the map maker. I could actually potentially build this in JavaScript within 2 months. Like what I'm trying to get built, and I'm still working on. I could probably build what I really want within about 2 months, just the map maker JavaScript. Major difference, it won't look nearly as pretty when I do it. All of my code and stuff look absolutely like bad when you. So the ideal is I would probably still be bad. Um, big. That's. I think it's the only thing that vibe coding really has on its side, comparably to like people who deal with like I normally make like databases. Um, I normally make any kind of manipulatable scenario with hashing. Like we go back to my repositories. Like most of my code stuff is some form of database or manipulating a data. Like here, this dungeon cross and this is randomly generated math crossword generated on the fly. 29 plus 19, but and so it's 18, 1, 8, so 3, 4, 8, and then 2 across. 17 plus 17, 14. That's 7 down. Ooh, 7 times. Oh man, I suck at multiplication. Holy crap. 42. You know what? Another way to figure it out. 3 across. 17 plus 79. Oh, wow. Okay, well, I can figure that out. I know that's going to be a 6 because the 7 goes in. It's 1 minus. It's a 1 over. So it's going to be 7, 8, 9. So 96. Hey, we figured it out. That's 49. What does this one was? 7 times 7 is 49. Oh, 4 across. Woo, boy. It's an addition, though. We got this. All right. So we got 5, 7, and then what? 7, and then 8, and then 5. So 5. Ooh. Oh, I've already messed. I messed up. I messed up. All right. Rethink again. So it's 5, 7, 7, 6. I did it. So would you believe me if I told you this was like partially vibe coded and partially hand coded? All of the puzzles are 100% auto generated. And if we keep going, we'll get to a point where it's like a big room. So you had these little boss battles. Um, so now you're starting to see why I want to make a map maker. I want to have better maps. And something I would like to get done, if I can actually get the pixel dungeon thing doing, the pixel background, um, is it will have a math mode where you to solve math equations, fight, to have attacks, you will use math equations. And you would be able to purchase in or buy in, not throw money, but like that, like higher forms of mathematics that will then do bigger things like, oh, I want to increase the number of digits in my plus, my additions, be able to get a larger range addition. Oh, I need some regular actual magic. Let me put in some multiplication. Let me get some that multiply. Oh crap! Let me get some exponential type of math. Let me get some quantitative type math. Let me get multi-complex, 3-stage. That's serious. That kind of crap going. And like for example, drug wars. Oh yeah, wars. So drug wars has this thing. That's what I actually made the simulated world drug wars. Um, web apps. Nice. interactive character sheet. So like here's one where I got Brock to help me with the crashing. All right, so we have Drug Wars. This, if you don't remember, there was a game a long time ago. It's called something called Dope Wars. Very similar. Does not look as good as this. I don't close it. Pull this one. I just always think that wallet. It looks just the same. So as you can see, we haven't done anything, so the game hasn't even started. The game still has not. Go ahead and start the game. Um, borrow some money. Start of the day. We got a little bit of debt. We got some debit and we got some debt. All right. Go to Discover. Okay, let's go try to find something. Go to Discover. Did we get some drugs? Oh, look, we got drugs. Let's go sell that. Um, specifically, right, that's right, because that's not what I'm thinking. Right, sell that. Do we got money? Do we got money? We got a little bit of money. Let me buy a little bit of that. Discover. Oh, we got a person on our side, bro. We got someone on our side. Look, man. Look, man. See. Sell that. Else. Deal. Go Discover. Whoa, another one bites the dust so you can sell it. Oh, hell yeah. Hell yeah. Oh, wait. I'm losing gas going out doing these discoveries and these deals. Holy crap. LSD, yeah. CBD, some spice. I'm keeping that Valium, alright? Ooh, meth is on the market. Let's grab some meth. Let's see if we can disrupt the meth market. I got two rivals with no fucking dumb, and I am taking their loot. Let me, let me return some of my money so I have less debt. Let's go see if I can discover. Let's see if we can make some sales, baby. Come on. It froze. So sometimes when we simulate the time in the game, um, getting a bug or an error. Now this is completely hand coded. This one I did ask Brock to help me figure out some issues and stuff, but it's not actually coding. So this is like probably the best types of visuals I'm type thing. But the actual code is there. The stuff is complex. Like there's a series of names of rivals that we can get, places we can go to, new location, actually go to new location, and it has all these like little like it's all had on the fly notification system, um, all these little things, and it's doing that in JavaScript. So the amount of difference that we get in vibe coding really is visually it looks better. Automatically almost all the time it looks better. And then I'd say the other thing is that when it is producing, doing, or whatever, it's giving you this opportunity to really learn if you allow it. So the most people really do is they say, give this, fix this, do this. But if you ask it to teach you why is this error happening, you can then direct it in a manner that will prevent that error. Learning while vibe coding, to me, is the best excuse to vibe code. Thanks everybody for showing up. I really appreciate you guys joining in and watching me goof off on here. We did come across some errors I didn't know I had. I literally am just going to come in here and now I know the save arc doesn't work. I'm going to go in and get it, like, fix that. Or I'm probably going to ask it, how do I fix this? I'm probably going to spend the afternoon learning how to actually fix that save arc button so I can actually like save my arcs again. And it could be something as simple as I'm noticing there's nothing. I don't have any arcs in my arc. I don't know, but I gotta figure it out, and then I gotta come here and do another series of tests, and I'll make some pages and make maps, and see if we can load them back in, see what messes up, see how it saves stuff properly, and all that stuff. Because this is turning out actually kind of fun. And if you guys didn't notice, I'm gonna name off some of the stuff that is an object. So it's something you can place down onto the grid that the system has some form of knowledge about. So a walk space, non-existing untouchable land, not a part of map, barrier, a wall, a waterfall which acts like a barrier or wall, it's non-interactive, a waterfall which acts like a barrier or object that is interactive, an almond water supply, climbable wall, climbable object, interactive object, object chest, user chest, door, non-interactive window, start, window middle, window in, break and ground start, break and ground middle, break and ground in, boss door, boss spawner, mini boss spawner, trap, weapon, armor, tool, enemy, encampment, mini boss group, camp, seize, safe zone, ladder way, up or down, pole, down only, rope, up only, teleport home, teleport instance or waypoint, puzzle piece, vending unit, boat, water, deadly, boat only, water, swimmable, skill, need, property select. You know one thing I don't have? Just regular water. The only thing we don't have. And we don't have lava. But we do have deadly water that we could